Hello everyone. Last time we have discussed how to make the combination circuits of series resistance and parallel resistance. Today we will try to solve numericals on them and also see how to solve cases if both kinds of combinations are present. That means in a circuit previously we have solved for cases only having series, means resistances are always in series or always kept in parallel to each other. In case of only series, we have solved using the formulas. But what to do if both combinations are present in a single circuit? Let's see. Looks like if I have a circuit like this. Here the first resistance is 1 ohms. These two are in parallel are both 4 ohms and this one is 1 ohms. Then how to solve this problem? Clear? That answer is very simple. If at any case it is given like only the series and parallel both are present, you first solve the parallel one. Clear? First we will solve parallel, then we will add it like series. So for two resistance of 4 ohms in parallel, we got the value so 1 by R equals to half and R equals to 2 ohms. So from the parallel connection of 4 and 4 ohms, what do we got? We got a net value of resistance 2 ohms. Clear? So we got 2 ohms from here like this. So you can now think the whole circuit is reduced to that. It was like this. Now instead of the two 4 ohms kept in parallel, what do we got now? A 2 ohms resistance in series. Like this. So previously it was 1 ohms, so it will be also 1 ohms, and these two were 4 ohms, so their corresponding resistance is 2 ohms. So it will give us 2 ohms here, the parallel resultant of these two, and here was 1 ohm, so it will be also 1 ohms and 1 ohm. So it's now clear that we have just got 1 plus 2 plus 1, and it's the net value of our resistance is 1 plus 2 plus 1. In total, how much? In total we are getting 1 plus 2 plus 1, 4 ohms in total. So what did we learn from here is that if I am given both series and parallel combination together, then first solve the parallel. Then add it with series. Clear everyone? So this thing we will follow while we are solving all kinds of numericals in our chapter. So let's try some numericals from the exercise to test our skills here. Let's clear the page. Yeah. We can look for the common numericals, which is number 10. Number 10 is quite like this, that this is the point A. Here is a circuit of resistance 2 ohms and another 2 ohms. Both 2 ohms are connected here. It's question number 10 in your exercise. Then two resistors are given in parallel. They are also 2 ohms. How to solve for this? Any idea? Very easy. We will first solve the parallel portion. What is the result? Now 1 by R equals to 1 by 2 plus 1 by 2. That is 1. So the parallel portion will give us 1 ohms. So the parallel circuit, this portion is now amounting to 1 ohm, and rest are two resistance of 2 ohms are added in series connections. So the net value is now 2 plus 2 plus 1, all three in series, and the answer is 5 ohms. Clear? So what we do at first? Now we first solved out the parallel portion. First found out the equivalent resistance of the parallel combination, and that value gave us 1 ohms. After that, I have added this value with the resistance, to the two resistors given in series. So 2 plus 2 plus 1, and the net value was 5 ohms. Clear? Similarly, we can solve more numericals of this kind, like question number 12. Question number 12 is also quite easy. It says that there is a point A. Here two resistances are given. And in the bottom section, two resistances are given. The values are like this. This one is 4 ohms. This one is 8 ohms. This one is X ohms. And this one is 5 ohms. They have said that in the circuit below, calculate the value of X if the resistance, equivalent resistance between A and B is 4 ohms. So I have to find out the value of this X resistance so that the resistance between A and B equals to 4 ohms. Clear? So this is our target, that what should be the value of X to get a 4 ohm resistance between these 2 points. So let's see what is with the upper portion of the circuit. Now 4 ohms and 8 ohms are connected in series. So this 4 ohm and this 8 ohm are connected in series. So the upper portion, this upper portion of the circuit gives us 4 plus 8, 12 ohms in total. And the lower portion is a little bit different. Lower portion is X ohms and 5 ohms. So the lower portion gives us X plus 5 ohms. Clear? So upper portion gave us 12, lower portion gave us X plus 5. Now we can see these two are in parallel. These two portions are in parallel. So the net circuit reduces to be like, the upper portion is 12 ohms and the lower portion is x plus 5 ohms with our points A and B. So if 12 ohms and x plus 5 ohms are in series, we have to find out the value of x for which the net resistance will be 4 ohms. Clear? So very easy. If 12 and x plus 5 are in parallel and the result is 4, so we all know the formula for parallel combination. The formula for parallel combination suggests 1 by R equals to 1 by R1 plus 1 by R2. 1 by R is the net resistance. For our case, the value of R is 4. The value of R is 4 ohms. The net resistance we have to get. R1 is 12 ohms. R2 is x plus 5. So I will just put these values in the equation. What will I get? Let's say that 1 by 4 equals to 1 by 12 plus 1 by x plus 5. So it's now everything is easy. Since 1 by x plus 5 equals to 1 by 4 minus 1 by 12. The answer is, that is 2 by 12. So 2 by 12 means 1 by 6. Clear? So 1 by x plus 5 equals to 1 by 6. So let's see. Solve out the last part. 1 by x plus 5 equals to 1 by 6. That's what we reach at the end. Hence, x plus 5 equals to 6 ohms. Hence, the value of x is 6 minus, sorry, I must not write the ohms right now. The value of x is 6 minus 5, that is 1 ohms. So, hence, the unknown resistance we get is 1 ohms. Clear? We can also solve similar numericals of different circuit problems like this, and they are very helpful in solving different kind of numericals. Let's do one more example, which is question number 17. Question number 17 is like this. They tell us that between A and B, on the upper portion I have got two resistance 3 and 3 and 3, both are 3. No, sorry, this one is given to be 2. In the mid portion there is also a resistance given. That resistance is quite large. Its value is 30. In the lower portion also two resistance are connected here like this. Their values are 6 and 4. So you can see in the upper portion of the circuit, just see these 3 ohms and 2 ohms are actually connected in series. They are not connected in parallel. Where the one resistance ends, the second resistance began. So these 3 and 2 will give us 5 ohms. And in the lower portion, the 6 and 4 are connected in series again. Where one ends, the next began. 10 ohms. And in the middle, I have got a 30 ohms. So what I got? I got 3 resistance in parallel. On the top portion, 5 ohms. On the lower portion, 10 ohms. And in the middle portion, 30 ohms. So we can make the easier circuit, the reduced circuit like this. Like this. This is 5 ohms, this is 30 ohms, and this is 10 ohms. As a final circuit, now it's a child's play to calculate the resistance between them. So 5, 30 and 10, 3 are in parallel to each other. 3 are in parallel to each other. So what should be their net value? See the normal using the formula 1 by r equals to 1 by 5 plus 1 by 30 plus 1 by 10. Perform the LCM. So it's 10 by 30. That means it's equal to 1 by 3. So 1 by r is equals to 1 by 3. So the net resistance is 3 ohms. So this is the question number 17, how we solve it. So these numericals are quite easy to solve. Clear? We will solve few more numericals further, but for not now today, we will do it next day. So all the students, what is your homework for today? Now you have to solve numericals up to question number 20. So that is your homework. Solve only numericals 1 to 20. That is your homework for today. Clear? For this week, you finish this stuff and give me on the next class. Okay? And if any doubts are there, we will solve in the group. I will send the solutions in the group and you can check it. So I hope this topic is clear. Thank you everyone. See all of you next week.